video, we want to find the integral of 1 over 3 minus 2 cosine x dx. So we're going to use a half trig angle identity. Let's start with t. We're going to let t equal tangent of x over 2. And so taking the derivative of t, we're going to take the derivative tangent of x over 2, which is secant squared x over 2 times a half. So we'll put the 1/2 in front, dx. And so here we want to solve for dx, so we'll multiply both sides by 2. And then we want to move secant squared to the other side. So we're going to multiply both sides by cosine squared. But the problem is you want to have cosine squared x over t in terms of x over 2 in terms of t. So what we have to use is the double angle identity. So we'll start off with cosine x. That's going to equal cosine of 2 times x over 2, which is equal to, this is a double angle identity now, it's cosine squared x over 2 minus sine squared x over 2. So now what we have is tangent of x over 2, so the angle is x over 2. And when you're looking at tangent, think of this as opposite over adjacent, so that's t over 1. And this will be the square root of t squared plus 1, using the Pythagorean theorem. So if you want cosine squared of x over 2, that's going to be adjacent over hypotenuse squared, minus, and then sine of x over 2 is opposite over hypotenuse, and then we have to square that. So if we simplify, we have 1 over t squared plus 1 minus t squared over t squared plus 1. And so we get 1 minus t squared over t squared plus 1. So that's going to equal cosine. And that's what we need to plug in. So up here we have 1 over 3 minus 2 cosine x, but we said cosine was 1 minus t squared over t squared plus 1. And then for dx, we said dx is 2 cosine squared x over 2 dt. Which, for that one, we need to solve. So cosine is 1 over square root of t squared. So cosine x over 2 is 1 over square root of t squared plus 1 squared. And then just multiply both sides by 2. So that's going to be 2 over t squared plus 1. So that's what we're going to multiply by. And then dt. So now we multiply this. So we have 2 on the top, so we'll just bring that outside. And then it's dt. Over on the bottom, you want to multiply t squared plus 1 by both terms. So 3 times t squared plus 1 is 3t squared plus 3. And then minus, so we'll multiply t squared plus 1 by negative 2 times 1 minus t squared. But actually, it's going to cancel with the denominator. So we have negative 2 times 1, and then negative 2 times negative t squared. So we have 2 dt over 3t squared plus 2t squared is 5t squared, and then 3 minus 2 is 1. So now we need to integrate this, which kind of looks like 1 over t squared plus 1, but not exactly. So our goal is to get it into t squared plus 1, so we're going to make a substitution. We'll let u equal the square root of 5t, so du square root of 5 dt. And if you divide both sides by root 5, that's where you get dt by itself, so I'm going to put that outside. And then for t, we're going to have u over root 5. Simplifying this, you have u squared over 5 times 5 is u squared plus 1. And then if you integrate this, that's going to be arctangent of u plus c, but remember we said u was square root of 5 times t. And then t, we said, that was the first thing we said was tangent of x over 2. So this is the final answer.